So in the previous lecture, we were discussing method of undetermined coefficients, method of undetermined coefficients. For solving higher order ODEs, for solving higher order linear ODEs. In fact, this method helps us to find particular solution as well as general solution of non-homogeneous higher order linear ODEs with constant coefficients. So I explained you the method in the previous lecture. Today we are going to discuss a couple of examples of this method, and then we'll move forward. I told you that the particular solution of any non-homogeneous differential equation with constant coefficient is basically a guessed solution. We guess the solution motivated by the right-hand side of that differential equation. For example, in the case of a polynomial function, it depends if the right-hand side of the differential equation is a polynomial function or exponential function or trigonometric function, means sine or cos. It depends on the nature of the right-hand side function. By looking at the right-hand side function, we assume the particular solution, and then we find the general solution. Of course, example, we need to solve the following ODE: y double dash plus 4y dash minus 2y equal to 2x squared minus 3x plus 6. Whatever it is, as you know, the general solution is basically what? The general solution is of this differential equation would be y of x, which is the sum of complementary function or complementary solution plus the particular solution or the particular integral. The complementary solution is the general solution of the associated homogeneous differential equation, okay, of the associated homogeneous differential equation. So if we want to find the complementary solution or the complementary integral of this differential equation, then where yc is the homogeneous, is the solution of associated homogeneous ODE. That is what the homogeneous ODE associated with this is what you just simply write the left-hand side of this differential equation or the homogeneous part of this differential equation. So yc will be the general solution of this differential equation. The general solution of homogeneous differential equation is a different thing, and the general solution of non-homogeneous differential equation is a different thing. Okay, keep this in your mind. So in order to find yc, we write the auxiliary equation or the characteristic equation. How do we write it? We write it m squared plus 4m minus 2 is equal to 0. And then it is obviously, can we factorize it? No? We can find the roots by using quadratic formula, of course. Minus b, it is -4 plus minus k root of 16 minus plus 4 to the 8 divided by 2, and it is -4 plus minus 24. 24 is what? 203? No, 206 divided by 2, and it is 9. It becomes -2 plus minus the square root of 6. Okay, these are the roots of the given differential equation. Obviously, if these are the roots, they are distinct and real. They're real and distinct. So we can write the general solution. The general solution of let we call it equation 2. Okay, equation 2 is what? Is y. In fact, it is yc, complementary solution or the complementary function. It is obviously a constant c1 times e raised power -2 plus √6 times x plus a constant, another constant times exponential of 2 minus √6 times x. So this is your complementary solution. Now, we need to find the particular integral or the particular solution of this differential equation 1. Now, I told you that the particular solution of any non-homogeneous differential equation of this kind is assumed by looking at the right-hand side. Now, what is the right-hand side? Right-hand side is a second order, second degree polynomial. Second degree polynomial. So we assume that the yp of the given differential equation, the particular integral of the given differential equation is ax squared plus bx plus c. So we assume a second degree polynomial as a particular integral where these a, b, c, where a, b, and c are undetermined coefficients. So these are undetermined coefficients and we need to find it. So that is why we call it method of undetermined coefficients. So what we do, if this is the solution of the given differential equation, then it must satisfy the given differential equation. Okay. If it is a solution, we assume that this is a solution, particular solution of the given differential equation. So it must satisfy the given differential equation 1. Okay. So we need to put this solution into equation 1, which is the originally given equation, this one. In order to put that solution here, we need a second derivative, first derivative, and then we'll put it here. So we find yp dash of x is what? 2a times x plus b, and the second derivative of this thing is yp double dash of x is 2a. So now we are going to insert this solution into the given differential equation, which is y double dash. Y double dash means 2a plus 4y dash, which is 2a x plus b, and minus 2y. What is y? Ax squared plus bx plus c. And this is equal to what? 2x squared minus 3x plus 6. Now we have this equation. Now we are going to compare the coefficients on both sides. How we can compare? We can compare coefficient of x squared on the right hand side with the coefficient of x squared on the left hand side. Okay, so we have to first arrange these terms according to the terms given in the right hand side. Okay, so the coefficient of x squared is you can write 2a. This is the coefficient of x squared. No x squared is involved in any other term, so this is the coefficient of x. Now plus the coefficient of x is what? This 8a. Coefficient of x is here, and then coefficient of x is here. We had minus 2b times x. And then the constant terms, which is plus 2a, this is the constant term. Here 4b is the constant term. And here minus 2c is the constant term, which is equal to 2x here minus 3x plus 6. Now we can compare both sides. We compare the coefficient of x here on both sides, coefficient of x on both sides, and the constant on both sides. We get comparing the coefficients of you can say like powers of x. We obtain, what do we obtain here? Let me write it over here. The coefficient of x here is negative 2a. It should be equal to 2. And 8a minus 2b is equal to the coefficient of x's, which is minus 3. And 2a plus 4b minus 2c, it should be equal to 6. So this is what we obtained as equations. Okay. Now these equations can be solved simultaneously, or you can write the corresponding coefficient, the corresponding non-homogeneous linear system. Okay. We can write a linear system out of this system, which could be what? Negative 2, 0, 0, 2, and 8, negative 2, 0, negative 3, and then 2, 4, negative 2, 6. So this is your linear system in the unknown variables A, B, C. You can write the corresponding augmented matrix. Augmented matrix can be solved, and you can easily find the values of these constants. Okay, I hope you can do it because you have already studied these things in linear algebra. Okay, you would convert this matrix into echelon or reduced echelon form, and then you can solve for the constants A, B, and C. What do we get here in short is negative 1, the values of A. After solving it, we obtain A is equal to negative 1, B is equal to minus 5 by 2, and C is equal to minus 9. Okay, so we obtain these values after either solving this thing simultaneously, or we can solve this augmented matrix, or you can write the linear system, or you can use any method used in linear algebra to solve this system of linear equations. So after solving these constants, so these A, B, C are undetermined coefficients. Now they are determined. We can put these values here in this assumed solution. Here it is negative x squared minus 5 by 2x minus 9. So this is your particular solution of the given differential equation. Now, what is the general solution? The general solution of the given differential equation is the sum of complementary solution and particular integral. Okay. Now we can write the general solution of the given differential equation, which is the complementary solution is given there is C1 e raised power negative 2 plus under 6x plus C2 e raised power negative 2 negative under 6 times x, and then minus x squared minus 5 by 2x minus 9. Okay, so this is your general solution of the given differential equation. I hope you get it. If you have any question, if you have any confusion, you can ask me. Because the question is, how do we know that the form of the particular solution is a polynomial of degree 2? We assume a particular solution by looking at the right-hand side function. If the right-hand side function is a polynomial of degree 1, we assume the particular solution as a polynomial of degree 1. Okay. If the right-hand side is constant, we assume the particular solution as a constant. If the right-hand side is an exponential function plus a polynomial function, then we assume the particular solution as a polynomial function plus an exponential function with some constant. Okay. Similarly, if the right-hand side is sine x or cos x or sine 3x, sine alpha x, cos beta x, then we assume the particular solution accordingly. I think you have missed the previous lecture. So that's why you don't know. Kindly see the previous lecture. You would definitely understand how do we write, how do we assume the particular solution. A particular solution is basically the idea behind choosing or assuming the particular solution is basically we assume an educated guess motivated by the right-hand side of the differential equation. Okay, if the right-hand side has polynomial function of some particular degree, we assume the particular solution is a polynomial function of the same degree. Okay. For example, here is another example. Let me change only the right-hand side so that I can quickly go through different particular solution, form of particular solutions. For example, the right-hand side is 2 sine 3x. Okay. Then complementary solution, we assume that by P of x is what? Yeah, constant times sine 3x plus a constant time cos 3x. Okay. We assume this kind of solution. Why do we assume sine 3x plus another constant cos 3x? Because if we assume sine 3x only here, there'll be no cos 3x. But whenever we insert this solution into the differential equation, it has derivative. It has derivative term. Then the derivative of sine 3x would become a cos 3x. So we need another thing to compare on both sides. So that is why we use sine 3x and cos 3x. Even if we have minus 5 cos 3x here, still we'll assume the same solution. But if we have sine something different here, maybe 4x, then in fact, we'll assume two different solutions. One for this term, which is this one, plus for this term, because this term is entirely different from this term. Okay, and then we'll use principle of superposition by adding two solutions. And similarly, if the right-hand side is now, in order to find the solution of this differential equation, what we do, we insert this particular solution, assume particular solution into this differential equation, and then we try to compare coefficients on both sides. Now there is no polynomial here. What we do here, we'll compare the coefficient of sine 3x and cos 3x on both sides. As there is no cos here, so we can assume that cos 3x, the coefficient of cos 3x is 0. Okay. So by inserting this into the given differential equation and then comparing the coefficient of sine 3x and cos 3x on both sides, we can again have a system of linear equations in the unknown coefficients. And solving those linear system, which contains unknown undetermined coefficients, we can find the values of those coefficients. I hope you get it. If anyone has any question, you can ask. Now, if there are sums or products, I also told you that what kind of functions, if we have on the right-hand side, we can find the particular solution. There are some functions, if they appear on the right-hand side of this differential equation, then we cannot solve that differential equation using the method of undetermined coefficient. For that, we'll use method of variation of parameters. We'll use different method. For example, if we have maybe 1 over x here, then this method fails. This method cannot give us any solution. Okay, I have given you examples of what kind of functions this method fails in the previous lecture. Okay. Now, if for the functions which are allowed on the right hand side, if the product is involved, for example, if we have e raised power x, maybe 3, and maybe x squared here. Now we have a product of two different functions. The one function is a polynomial function and the other is exponential function. Now this is a polynomial function of degree 2. In this case, we assume the particular solution as a polynomial function of degree 2 into an exponential function. In this case, the assumed solution will be this. I have explained all these things to you in the previous lecture, and I've also included some of the examples and exercises in my notes. You can look at those examples and the exercises, try to do them. If you have any question, if you have any confusion, you can ask me right now or in the next lecture. Okay. Now, there is another glitch in this method, which is important to mention here, is that this method fails in another situation as well. And what is that situation? Let me give you an example of that situation in order to explain you the glitch in this method. Now, if we are given this kind of differential equation to solve 8e to the power 4x. Now, we are going to solve this differential equation. For the complementary solution, we write the characteristic equation. Characteristic equation is what? It is m squared minus 5m plus 4 is equal to 0. Now, after solving it, we can obtain the roots as minus 4, minus 1. And that is, I think, 1 and 4 are the roots. Now, the complementary solution is what? Complementary solution is a constant C1 raised power x, 1x, plus another constant times e raised power 4x. This will be the complementary solution. Now, look at the right hand side now. The right hand side is 8e raised power 4x. We assume the particular solution as yp of x is some constant times e raised power 4x. Okay. Now, if we put this solution, this particular solution in that given differential equation, what happens here? Yp dash is what? It is 4a e raised power 4x. And then y double dash p of x is 16a e raised power 4x. Okay. Now, inserting all these three things here in that equation, what do we get? 16a e raised power 4x minus 5 4s are 20 a e raised power 4x plus 4 e raised power 4a e raised power 4x. 4 a e raised power 4x, and this is equal to 8 e raised power 4x. Now, look at the left hand side. It is 20, negative 20, plus 16, and plus 4. It is 20 again. So this sides basically give us 0 is equal to 8 e raised power 4x, which is not possible. What does it mean? That this method cannot give us the value of a coefficient a for the assumed solution. This method fails. Okay. This method fails here because we are unable to compute the value of this coefficient, undetermined coefficient a. Why it fails? Because our assumed solution is also present in our complementary solution. Okay, our assumed solution, which is a constant time e raised by 4x, is also present in our complementary solution. C2 a constant times e raised by 4x. Whenever our assumed solution is present already in the complementary solution, this method fails. What do we do in this case? We improve the particular solution. Okay, we improve the particular solution by writing now. We assume that the particular solution is now a constant times x power n e raised power 4x. We multiply the particular solution by x power n, where n is the smallest integer which removes the duplication of yp in yc. Means if we put here n is equal to 1, means if we choose n is equal to 1, then it will be x power 1, or you can say that in this case yp of x will be a times x times e raised power 4x. Now put this solution again in the given differential equation. If this solution gives you the value of undetermined coefficient, then it's okay. The value of n will be 1. If again this method fails, you multiply this solution with x squared. Again check, put that solution in the given differential equation. If that gives you the value of undetermined coefficient a, then it's okay. Otherwise, you continue this procedure until you get the value of that undetermined coefficient. I hope you get it. If you have any question, you can ask me. I think it's easy. It's not that much difficult. Okay. Now you try this particular solution in order to find the particular solution and try to find the value of this undetermined coefficient a. If you can find the value of a, then it's okay. You stop here. Otherwise, multiply that original particular solution with x squared and then do it again until you get the value of a. This was a glitch in this method. It's basically a shortcoming in this method, which can be handled in this way. Basically, in the duplication, you are assuming particular solution as a part of the complementary solution. So here is a duplication. So whatever the value of constant a here is, if you have, if for example the value of a is 4 or whatever it is power 4x. Then if you choose, because this is a general solution, C1 and C2 can take any values. If you choose it -4, these two terms will be cancelled out. Your solution will be reduced. You'll have not a unique solution, okay? Or your solution will not be, basically it will not contain complementary as well as particular solution, okay? Or whatever you choose here, the value of constant, maybe 8. Then you can sum up these two terms, 8 plus 4, 12. Then you would definitely lose the particular solution. Okay, you'll have only this term, because this basically changes your solution. If the particular solution is already present in the complementary solution, you find the value of constant, then it will change your solution.
The particular solution increases the number or increases the number
देखिए उसमें फिर राइट हैंड साइड का पर्पस नहीं रहता ना आपके पास. If then this equation will have same solution if you are unable to find, or if you have this kind of solution for the right hand side, which will be simplified along with this term, then that would be a solution of simply the homogeneous part of the solution. Then there will be no contribution of the right hand side in the solution. Okay, if there is no contribution of the right hand side in the solution, then obviously there must be a problem. So that's it from my side for this method of undetermined coefficients. There are many other examples given in my notes. You can try them, you can practice them. If you still get any problem, you can ask me in the next lecture. Right now, if you have any question, you can ask me. No, that's sufficient. I don't process. Now let's try some application of second order differential equations. We'll start it by discussing spring mass systems. Let me change the board. Camera. You see it? I hope now. Not sufficient. Okay. The application of second order differential equations. Application of second order differential equation include different physical phenomena. For example, we have already discussed RLC circuits. We also obtain a second order differential equation when we model RLC circuits. Otherwise, what we are going to discuss as an application is spring mass systems. Spring mass systems. What is a spring mass system? In fact, if we have a rigid support, fixed support, and a spring is connected with this support. Okay, this is your spring. Its length is L. Okay. This is a rigid support, means this wall is fixed, it cannot be moved. And a spring is hanging with this wall or ceiling or whatever it is, whatever support is this, a spring is hanging with this rigid support. Now, when or if we with this spring, maybe we attach a mass, a body of mass m, of any object of mass m, then definitely there will be an extension or elongation of this spring. Okay, it depends on the mass of that body. If we attach a mass, then here. Okay. So originally length was this one. Okay. यहाँ पे length कितनी है? ठीक है. After attaching a body or an object of mass m to this string, definitely there will be a stretch in this string, and we assume that this stretch is S. Okay. While there is a stretch in this string due to what? Due to the weight of this object. Okay, the weight is basically a force which is basically applying on this object in the direction towards the earth, you can see. And weight, this force weight is mg. Okay, there is another force which is pulling back this mass towards upward. Okay, and that force is what? It is restoring force, Fs. We denote it by Fs. Now by Hooke's law, I think Hooke's law, आखिर में E होता है इसमें? E होता है ना? I don't exactly remember. Let me check it. Hooke's law. What does this Hooke's law tell us? That the force which is basically applying upward, okay, in the direction opposite to the weight of that object. Hooke's law tells us that Fs is directly proportional to the stretch in that string. Okay, S stands for stretch. Okay, that's why we call it Fs, and Fs is a restoring force. Restoring force. Okay, when this mass or this object is at rest, okay, then, or you can say the equilibrium position, when this object is in equilibrium position, that is, it is not moving upward or downward, that is your equilibrium position. In that case, weight of that object must be equal to the restoring force of applying on that. Okay, applying basically upward, depending on the spring. Okay. Now, if this is Fs is proportional to directly proportional to S, then it means that Fs is equal to some constant K times S. Okay. And there must be a negative sign here because the direction of the force is exactly opposite to the direction of the basically the weight force. The negative sign represents that the direction of this force is opposite to the direction of this weight force. So Fs, not alpha, Fs, this restoring force is negative of K times X, S, where K is what? K is called spring constant. Why it is called spring constant? Because this force depends on the nature of the spring or the strength of the spring. Okay. So that is why we call it K is the spring constant. Now at the equilibrium position, these two forces are same. Now W is what? It is mg, and Fs is what? It is K times S. Now here we do not write here a negative sign. Why? Because these two forces are equal. We are not considering their direction. They are equal. So when we take it on the other side, it becomes mg minus Ks. This is equal to 0. So this is the equation of equilibrium position of this object. When it is at the equilibrium position, there is no motion in this object. So we call it equation 1. Now there is another situation that if we pull this mass downward or upward, if we pull this mass downward or upward and release it with certain velocity or zero velocity or whatever, or we can release it by holding it, this object at rest, or we can release it by throwing it with a certain velocity, downward or upward. Okay, well, if we pull it downward, then we can release it by holding it only. That will be a position. When we release it from the rest position, or we can pull it upward with a certain velocity. Okay, similarly, we can pull it upward and then we can release it by holding it at rest, or we can release it by throwing at a certain velocity downward. Okay, so these are the situations. Now, let us discuss the third situation. In third situation, the spring maybe it's a bit long, is pulled down or upward, whatever, so that its original length was L, this much, and the stretch due to the mass is S, and we pulled it X units downward or upward, vice versa. Okay. Now, there are three kinds of stretch in this string. And by pulling it down further, X units, then we can release or we can leave this object from the rest position. We just leave it from the rest position. We can leave it with the upward velocity. We pull it upward with a velocity, certain velocity, and that there are three situations. We will discuss it later on. Now there is a stretch. We stretch down this object further X units, and then we'll leave it from the rest or from with a certain velocity, upward velocity or downward velocity. So if we release it from here, it will start oscillating. This mass will start oscillating, and there definitely there will be a motion, to and fro motion. Okay, or we call it simple harmonic motion. Okay, we call it harmonic motion or simple harmonic motion. All the to and fro motions are simple harmonic motions. Okay, forward and backward. In this case, in order to model this motion, of course, we need a Newton's second law. Newton's second law. What is the Newton's second law? Anyone?
F equals to MA.
F is equal to MA. F is equal to MA. So in other words, what is F? F is a force required to put a certain object of mass M at an acceleration A. Okay, so that is the force required. किसी भी चीज को at a certain acceleration move करने के लिए और उस object का mass M है, so we can calculate the required force by using this formula. And this formula is tremendous. It is used almost in every situation where we need to model the motion of object. Okay. Now, how much forces are being applied here on this phenomena? One is applying here downward, the weight force is applying here, which weight is mg, and restoring force upward fs, which is negative k times s. Okay. Any other force which is applying here? Now, the restoring force will be increased here. What? Why? Because the original length of the spring is L. Now, the stretch in the string is what? It is S plus X. This is now the stretch. Now, this restoring force would become Fs is equal to minus K times stretch 1 plus stretch 2. This is the S is a stretch 1, X is a stretch 2. Okay. So the restoring force will be updated and it will be equal to minus K times S plus X. Now the force here, which is required to move that object downward or upward, or the motion, this motion can be modeled here as a F. F is what? F is in fact M times A, or you can say that the force is what? It is W plus Fs is equal to Ma. Okay. The force here is applying on that, on this system is totally W plus Fs, and it must be equal to Ma. Okay. Now, what is W? Or we can bring this on the left-hand side, or we can take it on the other side. Okay. So I'm putting this here, where A acceleration is what? D square X by dt square. Okay. And this is equal to what? W is mg plus Fs is what? In fact, it is minus K times S plus X. Okay. Now, we can further write mg minus Ks minus Kx. Okay. By using equation 1, mg minus Ks is what? Mg minus Ks is equal to 0. So we put this thing equal to 0, and then we obtain that m d square x by dt square is equal to negative K times X. And then m d square x by dt square plus K times X is equal to 0. And then dividing this thing with m, what do we obtain? D square x by dt square plus K divided by m times X equal to 0, which is what? A second order differential equation with constant coefficients. Okay, we can simply solve it. Normally, we assume that dx squared by dt squared plus omega squared x is equal to 0, where omega is what? Where omega is square root of K times X, K over M. Okay, so this is your differential equation, which is a simple homogeneous differential equation with constant coefficient, and the order of this differential equation is 2. Now, the solution of this differential equation will give us general solution, which will have 2 unknown constants. In order to find those constants, what do we need? We need initial conditions. इनिशियल कंडीशन क्या होगी? पहले यहाँ पे मास था, हमने डिस्प्लेस किया, ठीक है, तो इसका डिस्प्लेसमेंट कोई अमाउंट होगी, ठीक है. हम कहते हैं कि एट टाइम इज इक्वल टू 0 द डिस्प्लेसमेंट इज, द इक्वेशन इज d square x by dt square plus omega square x equal to 0, and we assume that the initial condition which suits this phenomena are what? X of 0. When time is 0, the displacement is some constant, maybe alpha. Okay, and its velocity at time 0 is what? Is some kind of beta. Where alpha and beta are some real numbers, constants. Okay, so this differential equation, along with these initial conditions, it forms an initial value problem. Okay.
Sir?
जी बेटा.
Sir, at time equals to 0, हमें x का पता नहीं होगा कि like it's going to be equal to by how much we displace.
Yes,
Time.
we should know it. How much displacement we have pulled down that object. Okay. So this should be known. And also the initial velocity. If we just pull down the mass and we leave it, then the velocity should be 0 because we left it with an initial velocity 0 because it started moving from the rest. But if we pull it towards upward with a certain velocity, then the velocity, the amount of velocity, we should know it. With how much velocity we have pulled that mass upward or downward. Okay. So these things we should know. Okay. This is an initial value problem which describes free undamped motion. Undamped motion of the string. So of the mass of the object आप कह सकते हैं, of the object attached to that string, and the mass of that object is m. Okay. Now, what is this free undamped motion? Free undamped means there is no frictional forces applying on the motion of that object. Again, when that object will move upward and downward, it will oscillate. If there are no external air resistance or some other force, then it will move forever. It will oscillate forever. Unless there is some additional force which is trying to resist its motion upward and downward, which, for example, the air. I'll give you further examples later on when we'll discuss free damped motion. Okay, for the time now, for the time being, you just imagine that a mass, an object is attached to the spring, and there is no air around. It's basically that motion is happening in the space. There's no air resistance which is trying to stop the oscillation or the motion of that object. Okay, if you pull that mass, pull that object downward one time and you leave it, then this mass will oscillate forever. There'll be no, you can say, the motion will not be slowed down by exactly the oscillation, amplitude of oscillation will remain same. So these kind of phenomena are basically ideal, where we need to where we discuss free undamped motion. Okay, these are ideal conditions. These are not practical here on Earth. It is possible within some space area, but these kind of motions are not possible here on Earth because there are some frictional forces which will try to definitely slow down the motion, and eventually the motion will be stopped. The oscillation will be stopped. Okay. So these are called undamped motions. Now, there are certain restrictions. There are certain cases which we have for these initial conditions. Okay. Cases. Let me discuss case one, maybe. Whenever this x of 0 alpha is, whenever alpha is greater than 0 and x dash means beta is greater than 0. What does it mean? means we pull down the, no, both cannot be, alpha is greater than 0 and beta is less than 0. Beta is less than 0. Yes. Yes. Alpha is greater than 0 means we pull down the object. Okay. And we leave. Converting upward. Let me see it. ठीक है, ये होगा. We pull down the mass object. ठीक है, उसको ऑब्जेक्ट को हमने, जो भी मास m है उसको हमने पुल डाउन किया. ठीक है, पुल डाउन. ठीक है, अल्फा यूनिट्स. ठीक है, एंड वी release that object with an upward velocity. Velocity beta. In that case, the velocity should be negative. Okay, and this displacement downward is positive. In case 2, these two arrows will be reversed. ठीक है, केस 2 में आपके पास क्या होगा? अगर आपके पास अल्फा लेस देन 0 है और बीटा ग्रेटर देन 0 है, तो फिर क्या होगा? हमने इस मास को पुल्ड अपवर्ड किया. ठीक है, देयर विल बी अ कॉन्ट्रैक्शन इन द स्प्रिंग. आप पुल डाउन नीचे करेंगे तो उसमें क्या होगा? बेसिकली स्ट्रेच होगा. जब आप मास को अपवर्ड पुल करेंगे तो उसमें स्ट्रिंग में जो भी आपका स्प्रिंग है उसमें क्या होगा? कॉन्ट्रैक्शन होगी. ठीक है, जब कॉन्ट्रैक्शन होगी तो आपने क्या किया? इसको आपने पुल्ड अपवर्ड, अपवर्ड m यूनिट्स अपवर्ड किया तो आपका डिस्प्लेसमेंट क्या होगा? नेगेटिव होगा. ठीक है, और आपने उस फिर जो ऑब्जेक्ट है उसको डाउनवर्ड वेलोसिटी से उसको रिलीज किया. ठीक है, तो यहां पे आपके पास फिर डाउनवर्ड वेलोसिटी आएगी. और डाउनवर्ड वेलोसिटी बीटा होगी ग्रेटर देन 0, और इस केस में डाउनवर्ड वेलोसिटी पॉजिटिव होगी. ठीक है. तीसरे केस में क्या होगा कि अगर आपके पास अल्फा ग्रेटर देन 0 है और बीटा इक्वल टू 0 है. चौथे केस में क्या होगा? अल्फा लेस देन 0 है और बीटा इक्वल टू 0 है. व्हाट डज दैट मीन? अगर आपका केस 3 में अल्फा ग्रेटर देन 0 है और बीटा 0 है, व्हाट डज इट मीन? आपने उसको पुल डाउन किया और फिर व्हेन द ऑब्जेक्ट इज एट रेस्ट यू जस्ट रिलीज इट विद 0 वेलोसिटी, इनिशियल वेलोसिटी. ठीक है, फिर चौथे केस में क्या है कि अगर अल्फा आपका लेस देन 0 है और बीटा अगेन 0 है, इट मींस आपने उसको पुल अप किया, पुल अपवर्ड, एंड देन you release it with the initial 0 velocity. Okay, so these are 4 cases. These are written in my notes. You can see them. I hope you can understand it. Okay, so these are 4 cases. Now let's come toward the solution of this mathematical model, which basically describes the free undamped motion. Okay. If you have any question, you can ask. Anyone? That's not possible. क्योंकि स्प्रिंग में जब कॉन्ट्रैक्शन होगी तो आप मजीद उसको ऊपर की तरफ नहीं छोड़ सकते. That depends कि उसमें फिर क्या सिचुएशन होगी, हम कैसे उसको मॉडल करेंगे. बट these are initial basic modeling of this spring mass system. इसको हम फ्री अनडैम्प्ड मोशन कहेंगे. फिर आपने जो नेक्स्ट मॉडल हम बनाएंगे वो होगा फ्री डैम्प मोशन. ठीक है. और इसको फ्री क्यों कहते हैं यहाँ पे? अभी आगे चल के फोर्स्ड अनडैम्प्ड मोशन या फोर्स्ड डैम्प्ड मोशन भी होगा। फोर्स मींस आप कोई एक्सटर्नल फोर्स भी खुद से कोई फोर्स जो है ना अप्लाई कर रहे हैं इस पूरे सिस्टम पे। मसलन क्या है कि आपका जो सिस्टम है उसमें, अच्छा पहले तो हम डैम्प मोशन करेंगे। फ्री डैम्प मोशन क्या है कि यू वुड डेफिनेटली कंसीडर द रेजिस्टेंस फोर्सेस व्हिच वुड ट्राई टू स्टॉप द मोशन ऑफ द ऑब्जेक्ट। रेजिस्टेंस फोर्सेस क्या होती हैं? मिसल एयर फोर्स है उसकी, ठीक है, जो एयर उसको अपोज करती है उसकी मोशन को, तो डेफिनेटली एक फोर्स है जो उसकी मोशन को अपोज करेगी। इवेंचुअली ऑसिलेशंस क्या होंगी? स्लो डाउन होंगी और इवेंचुअली वो डाई आउट हो जाएगी। दैट इज कॉल्ड फ्री डैम्प मोशन, जो कि रेजिस्टेंस फोर्सेस हैं जो कि इसकी मोशन को अपोज करती हैं, जो एयर हो सकती है या ये ऑब्जेक्ट जो है दैट इज इमर्स्ड विद इन सम अदर बॉडी, मे बी सम लिक्विड। ठीक है, आप क्या कर रहे हैं कि आपने ये जो है पानी की टैंकी में रखा हुआ है, स्प्रिंग पानी के अंदर है और आपने उसको मास अटैच किया। अब मास को आपने पुल डाउन किया, अब जो फ्लूइड उसके ऊपर एक फोर्स एक्सर्ट करेगा, ठीक है, तो उससे भी डेफिनेटली क्या होगा? रेजिस्टिव फोर्स होगी वो भी फ्री डैम्प फोर्सेस में आती है। ठीक है, लेकिन अगर आप पूरे सिस्टम को अफेक्ट कर दें यहां से, आप ये जो इसकी जो सपोर्ट है रिजिड है, इसकी सपोर्ट को अगर आप मूव करें विद अ सर्टेन फोर्स अपवर्ड एंड डाउनवर्ड, तो उससे भी आपके पास पूरे सिस्टम में एक और फोर्स, एक्सटर्नल फोर्स एक्सर्ट होगी, which is basically forced damped motions और forced undamped motion भी हो सकता है। उस केस में आप रेजिस्टिव फोर्सेस को कंसीडर ना करें, सिर्फ ये वाली कर लें एक्सटर्नल को, तो फोर्स्ड अनडैम्प्ड मोशन हो जाएगी, फिर फोर्स्ड डैम्प्ड मोशन हो जाएगी। ठीक है, तो देयर आर डिफरेंट सिचुएशंस। जो फोर्स्ड डैम्प्ड मोशन होगी या जो फोर्स्ड मोशन होगी वो हम इक्वेशन की राइट हैंड साइड पे अप्लाई करेंगे। ठीक है, जो एक्सटर्नल फोर्सेस होंगी वो यहाँ पे राइट हैंड साइड पे आएंगी। ठीक है, जो सिस्टम पे फोर्सेस अप्लाई हो रही हैं इंटरनली इंक्लूडिंग रेजिस्टेंस फोर्स, वो उसके लेफ्ट हैंड साइड पे होंगी। ठीक है, जो एक्सटर्नल फोर्स होगी वो राइट हैंड साइड। जब राइट हैंड साइड पे एक्सटर्नल फोर्स आएगी तो ये नॉन होमोजेनस डिफरेंशियल इक्वेशन बनेगी। ठीक है, विल डिस्कस these cases after free damped motion. Now we are going to solve this thing. And where do we use these things in our daily life? We'll discuss some daily life examples as well. Where do we use these kind of models? Now, if we are given some example, we can solve this generally as well as we can solve it with the help of some example as well. बाकी इसमें कुछ पीरियड ऑफ मोशन ये भी है। पीरियड ऑफ मोशन क्या होता है? पीरियड ऑफ मोशन ये चीजें आप देख लीजिएगा नोट्स में। पीरियड ऑफ मोशन it is denoted by t and it is omega by 2 pi, I think 2 pi omega, I think 2 pi omega, not omega by 2 pi. It's 2 pi by omega. What does this tell us? The period of motion is described by t is equal to 2 pi by omega, where t represents the time measured usually in seconds it takes the mass m to execute one cycle of motion. Okay. Period of motion is what? Period of motion is if this mass is attached to certain spring, then after pulling it down or doing certain thing, it will definitely oscillate, okay, up and down. So period of motion is what? Is the time in which one cycle of that oscillation is completed, okay, upward and downward. In fact, this is exactly in a straight line. Okay, One cycle, it starts from here and it goes backward here. That is the period of motion. Next is the frequency of motion. Frequency is what? Frequency is denoted by F, and it is 1/T, and it is what? Number of oscillations per unit second. Per second, you can guess it. Number of oscillations per second is the frequency of the oscillations or the simple harmonic motion. And other things you can see in my notes. Let's do an example of this thing and then we'll finish it. Now, what is omega here? Omega is what? You know the omega. Omega is omega square. Then omega is what? It is square root of what? K over m. K over m, where K is the spring constant and m is the mass of that object. Okay. There is an alternative form of the solution which tells us basically the amplitude of the motion. Okay, the amplitude is what? It is, if this is the equilibrium position, the amplitude is what? It is the distance. No, it's the total distance here. I think this is the amplitude of the motion. Amplitude means the maximum distance from the origin to the maximum position. I think this is the amplitude. Amplitude is the halfway distance. I think it is halfway distance. Equilibrium position say the maximum distance hota hai upward, that is the amplitude of this motion. You can compute it by writing the alternative form of the solution. Alternative form of the solution, I hope you can do it. Try it yourself in your free time, and then in case of any confusion, you can ask me any question in the next lecture. An example of this thing is, now we're going to discuss free undamped motion. Damping forces are basically frictional forces. Example. A mass weighing 2 pounds stretches a spring of 6 inches. Spring length is 6 inches, and the mass weight, if we attach 2 pounds of weight to that spring, it stretches, no. This is, the mass weighing 2 pounds stretches a spring 6 inches. So we have a spring mass system. We attach an object of weight 2 pounds to that string, and that spring is stretched 6 inches downward. Okay. At time t is equal to 0, the mass is released from a 0.8 inches below the equilibrium. Okay. At t is equal to 0, the mass is released from a 0.8 inches below the equilibrium position. Okay. What does it mean? X of 0 is 8 inches. Okay. Below the equilibrium position means it will go upward. So it will be positive. Okay. It is positive 8 with an upward velocity of 4/3 feet per second. With an upward velocity means x dash of 0 is 4/3 feet per second. And because it is upward velocity, so it should be positive. Okay. Upward velocity positive hoti hai, negative hoti hai? Upward velocity negative hogi. So this should be negative. So upward velocity is always negative. Okay. Remember this. If it is downward velocity, then it is positive. Because कोई भी अगर फ्री फॉलिंग ऑब्जेक्ट है तो उसकी डाउनवर्ड वेलोसिटी पॉजिटिव होती है, अपवर्ड वेलोसिटी उसकी नेगेटिव होती है, ये होती है ना, यही होती है, क्योंकि g इज ऑलवेज पॉजिटिव, ग्रेविटेशनल कांस्टेंट होता है, ग्रेविटेशनल एक्सेलरेशन होती है, acceleration due to gravitational force is always g is positive. So this is what we are given. We need to model this motion and try to solve that motion of the object. So हमारे पास इक्वेशन क्या होती है, dx square by dt square plus omega square x equal to 0, और यहाँ पे आपके पास x of 0 is 8 inches given है, और x dash of 0 जो है वो 4/3 feet per second given, ठीक है। अब ये अगर फीट में है तो इसको भी फीट में होना चाहिए, ठीक है। सो इट शुड बी कितने इंचेस होते हैं फीट में, 12, सो 8/12 इंचेस नहीं, ये फिर फीट हो जाएगा, सो इट इज 4/3 2/3 फीट। अब हमारे पास इनिशियल कंडीशंस हमें पता है, वी नीड टू कंप्यूट दिस w. What would be the value of w? W की वैल्यू हमें पता चल जाएगी अगर हमें k और m की वैल्यू पता हो, ठीक है। या आप इसको इस तरह भी लिख सकते हैं, दिस इज व्हाट इज m प्लस k टाइम्स x, ठीक है। आप ओमेगा ना लिखें, इस फॉर्म में लिख दें, m और k की फॉर्म में लिख दें, ठीक है। नाउ वी नीड टू नो m and k. For that we use we know that w is what, w is mg, where mass w is given 2 pound. We can compute m and g. The value of g is normally given, and if this is in pound, this is UK based SI units. अगर LB यहाँ पे लेते हैं तो UK based जो and g की वैल्यू लेंगे वो 32 something. You can see in my notes. From here you can find the value of m, which is 1/16, with some units. Okay. mass की यहाँ पे फिर I think slug unit लेते हैं वो, ठीक है, ये आप देख लीजिएगा, ठीक है। तो m यहाँ से आ गया। अब दूसरी क्या चीज हम यूज कर सकते हैं, हम कह सकते हैं कि w इज इक्वल टू fs होता है, क्योंकि w वेट इज इक्वल टू रिस्टोरिंग फोर्स की इक्वल होगा। तो वेट हमें पता है 2 है, और रिस्टोरिंग फोर्स क्या होती है, k टाइम्स s। हमें k की वैल्यू चाहिए, s हमें पता है, व्हाट इज s, इट इज 6 2k, और k की वैल्यू आपके पास 1/3 आ गई with certain units. You can see the units, okay, in my notes. So the value of k is 1/3, value of m is 1/16. You can put them here. The value of m is the value of m is 1/16. You can put it here. It will be 1/16, and the value of k is 1/3. You can solve this differential equation along with these initial conditions. You'll get x of t. Okay, I hope you can do it, because this is simple second order differential equation with constant coefficients. After solving it, you have to find the values of unknown constants as well, C1 and C2.